Good day, everyone. So in today's class, we'll be looking at simple structure of matter. At the end of the lesson, we'll be able to know what makes up in matter and how this substance decide the state of matter. So let's dive into this. Okay, matter fills the universe in many forms. Okay, so everything that we can see with our naked eyes are matter. So let's explore what this matter really is and what it is made up of. Okay. All right. Now, firstly, let's talk about what matter is. Okay. Matter is anything that has mass and take up space, including you. Okay. So anything that has mass and occupies space is called matter. And what makes up a matter is called atom. Okay. It's made up of atom. Atom are just tiny particles, the smallest unit that can exist independently. They are too small for us to see with our naked eyes, but we need to use microscope. And with the help of this atom, it makes matter to exist in three forms. Okay, so matter exists in three states known as the solid state, the liquid state, and the gaseous state. And this three states is dependent on the temperature around that particular matter. Okay, now let's look into the atom itself that make up this matter. Now, this atom, that is the smallest particle, is also made up of some particles as well. We call this subatomic particles, which are the proton, the neutron, and the electron. The proton and the neutron can be found in the nucleus of the atom. Okay, so this is a sample of an atom. So the one in the center is called the nucleus. So inside the nucleus, we have what we call the proton and the neutron. And the electron is the one that moves on the orbit of the nucleus. Okay, so the one outside the nucleus, okay, are known as the electron. Now, the number of proton in an atom tells us the name of that atom. Like if you have 6 proton in an atom, that atom is called a carbon. Okay, but also we have what we call isotopes. Isotopes are just they are just atoms from the same element. Okay, for it, and the isotopes have the same proton. Okay, what is different in isotopes is their neutron. For example, now let's take carbon. For example, I already said that when atom has 6 proton, it is carbon. But the neutron part, when the neutron is 6, we call it carbon 12. But when the neutron in the carbon is 7, okay, we call it carbon 13. All right. So carbon 13 and carbon 12, they are isotope because they are from the same element called carbon. The only thing that made them different is their neutron number. For carbon 12, it has 6 neutrons. For carbon 13, it has 7 neutrons. That is why they are called isotopes, because they are atoms of the same element. They have the same proton number, but different neutron number. Now, we've already said earlier that matter exists in 3 states, either in solid state, in liquid state, or in gaseous state. Now, when you see matter in solid form, what you can easily notice, or what is happening within that solid form, is that the atoms that make up the solid state of matter are tightly packed. Okay, the atoms are tightly packed together. Okay, they are not space. There is no space between each of the atom in that particular matter. For instance, now, if you see a solid, maybe a solid like a stone, let's call this a stone. If this is stone, definitely the atoms in a stone are closely packed, no space. You can see they are closely packed. They are closely packed together. So that's one of the characteristics of the solid state of matter. The atoms are closely packed. But for when they're in the liquid state, the atoms are not really closely packed. they can freely move. So if this is liquid now, the atom in it are not as close to each other as that of solid state. And when they're in the gaseous state, they can freely move more than when they're in the liquid state. So the distance between the distance between two atoms in gaseous form is much more than that of the liquid form. Okay, so that's what differentiates the solid form, the liquid form, and the gaseous form. The the distance between them are much more as you move from solid to gas. Okay, now let's talk about the evidence that I've explained this tiny particle. There is a biologist called Robert Brown that observed how particles exist or how this atom exists. You know what Robert Brown did? He put some pollen grain inside water, okay, and he observed that after some time that the particles were moving. They're just moving randomly in that water, and then he said this must be random movement, and that experiment was named after him, Brownian motion. His name is Robert Brown. Okay, so he observed that they are moving randomly and they are also colliding with one another as they move. Okay, now a theory was now propounded, which is called the kinetic theory of matter. Okay, and it states that atoms and molecules are constantly moving and colliding. And while they are colliding, it said the more they have energy to move, the faster the more they collide. Okay, the more energy, the more the motion. Okay, the faster the energy, the higher the energy, the higher the motion, the random motion of the particle. So the word is that there is constant movement and constant collision of the atoms and molecules, okay, of a matter. So this is called the kinetic theory of matter. And still on this evidence, derivation concept came in. What is derivation? Derivation also deals with random movement of the molecules and atoms of matter. But in this case, from higher concentration to lower concentration. So it's the random movement of motion, the random movement of an atom, okay, from higher concentration to lower concentration. And there are factors that affect derivation. Temperature. When the temperature of the matter is high, definitely there will be higher movement, there will be higher random movement of the atom, because when there is higher temperature, the atom they gain energy to move. Again, another thing that can affect the derivation of atoms or molecules is the particle size of the atom. When atoms are smaller in nature, the size will not be a barrier. They can move faster. But when you have a bigger atom, it moves slowly. Okay, the random movement will be slow. Then last one is the concentration gradient. The concentration gradient is talking about it's talking about the gathering of the atom as you see the high concentration. So when the concentration gradient is higher, okay, when the concentration gradient is higher, then you have faster derivation. But when it is low, you have low derivation of atom. Okay, density also affects the last one. Density of the atom also affects the derivation of the atom. Okay, so aside from that too, we have another concept that we need to know that affect the movement or the motion of atom of a matter. One of them is pressure, especially in gas. Pressure in gas. Okay, pressure simply involves the rate at which the atom hit the wall of the container where the gas is. Let's say, for example, now you have a container. Every one of us, we are using gas cooker in our. Let me not say everyone, but almost everyone is using gas cooker now. Now inside a gas cooker, you have cooking gas being fed into it. Let me say this is the cooking gas container, and inside it you have the cooking gas in it. So what happened here? What happened here is when the atom are hitting the wall of this cylinder, okay, they are exerting pressure. Pressure is simply is force over area, the amount of force applied at a particular point. Okay, now when the collision of this molecule increase and they are now exerting more force on the wall, then we say that there is what higher pressure of the gases on the wall of the cylinder, or this time around we call it container. So the more the collision, as you are colliding with each other, it's just like when you are in a room, like 5 or 6 people in a room, and they are running up and down. Before you know it, when the other person one person push the other person, is going to part. The other person will hit his body on the wall, and the wall will feel that pressure. So the point here is the higher the collision of the atoms, and they are colliding with each other or with one another rather, then the higher the pressure. Then evaporation also can occur during this collision. We are looking at this concept for gases now. Now, evaporation can occur. What is evaporation? It's also the changing of liquid to gas. Okay, but this time around, it happens at the surface of the liquid. So whenever liquid is changing to gas, evaporation is taking place. But one thing you should know about evaporation is that it can take place at any temperature. Evaporation can take place at any temperature, and it occurs at the surface of the liquid. Let's say this is the liquid. Okay, for example, this time around. Now, it doesn't need to you don't need to boil the water before evaporation can take place. Whether the water is boiling or not, whether there is a source of heat like fire or not, evaporation takes place at any temperature. Now, what makes evaporation different from boiling is that even though there's similarity that both changes um, liquid state of matter to gaseous form, but the difference is that boiling occurs at a constant temperature. When that temperature has not been attained in boiling, when the temperature has not been attained, boiling cannot occur. But evaporation does not need any particular temperature. It occurs at any type of temperature to change the liquid to gas. And it only occurs at the surface of the liquid. But boiling occurs the entire liquid. If you have boiled the water before, you see that when water is boiling, you see that the whole liquid will be boiling together, not just the surface part. Even down, if you have a transparent boiler, you will see that the whole liquid in the container are all boiling. Okay, but for evaporation, it only takes place at the surface of the liquid. And boiling also occurs when vapor pressure equals the atmospheric pressure. Very important. So you'll be able to distinguish between evaporation and boiling. They are not the same thing. They are different in definition and concept. Okay. Now there's another concept again called the correction, adhesion, and capillary. It's still under the concept of atom. Now, correction and adhesion are two opposite forces. When you have forces that are holding atoms together, they are actually force of correction and force of adhesion. So what is the difference? Now the difference is that if it is force of correction, it means it is binding atoms together, but these atoms are from the same substance. For example, now when the atoms of water are binded together, we say that the force that is binding them together is what? Is correction or force of correction. Okay, but when you now have glass and water together, okay, now the force that is binding the molecule of glass and the molecule of water together is called adhesion. Okay, so they are both attractive force. They bind atoms together, but you should know that adhesion is for binding two atoms from different substances, while correction is for binding two atoms from the same substance. Okay, now capillarity just deals with the rise and fall of liquid in a narrow tube. As you could see here now, if you look at the diagram carefully, you see that you have liquid here, and these two, you could see that water could rise on it. And take note of the surface of this liquid. You could see that the meniscus, we call it meniscus. The meniscus is concave. This is okay. It is bending downward. Okay. Let me look at it properly. So it is concave because of this concept of correction and adhesion. Okay. Now look at this. This is concave shape, unlike this one that is convex. It's not just that, it depends on the substance. What is the content that is here is water. Why this one that is bent, the content inside it is mercury. So this is mercury substance. Okay, mercury substance is here. Now, why this one in this form, in concave form, and this one in convex form? It's very simple. We are going to be using this principle of we're going to be using principle of correction and adhesion to explain it. Remember that we have this defined them. Now, what is happening here? Why this one is in the concave form, the water content is in concave form, is because this tube, actually, take note, is also a glass tube. Okay, it's made up of glass. Okay. Now, why this water tip or meniscus is concave is because the the adhesion, take note, adhesion is the attractive force between molecules of different substances. Now, what happened here is that the adhesion between the molecule of water and that glass is higher. Okay, is higher than the cohesion of water. That is why uh, water could be in this shape. Okay, that is one. That is one for this one. But for that of mercury, is the opposite. Is the opposite. This is because this is in this shape because the adhesion between mercury molecule and the glass molecule is lower than the cohesion of mercury molecule. That is why it is in this shape. Very, very important that you know that. Another thing again is that water usually wet glass. If you put water in a glass cup and you decant that water, you find out that you still find some particle remaining there. That is another thing you can use to know that the adhesion between glass molecules and water molecule is higher than the cohesion of water molecule. So water wet glass because adhesion is greater than cohesion. Mercury does not wet glass because cohesion is greater than what adhesion. That's the simple explanation of what we are talking about. All right, that's the simple explanation to that. Okay, so I won't talk about that. Then let us look at practical application of capillarity. You know, we have just said capillarity is the rise and fall of water in a tube. Now, we can find this capillarity application in plants. Okay. Now, water, gets to the plant through capillarity. When you have a tree, for example, let's draw a tree that is being planted. Okay, just maybe a sample of this is a tree here. Let's just say this is a tree and it's being planted. Okay, now how will water get to the branches? This stem is representing the tube. It is through what? It is through capillarity. Water begins to rise and rise and rise and go and touch the branches and then supply nutrient to the plant or to the tree. That is through capillarity because it's the rise and fall of liquid in a tube. Then lab equipment. So, in the laboratory, we make use of different tube, the test tube, and carrying out your experiment. This is also possible because of capillarity. The wicking fabric, okay, like paper towel, can absorb easily because of this principle of capillarity. Even the ink in our pen can also flow smoothly because of what the principle of capillarity. So please take note that capillarity, is the cause of some of these incidents that occur. All right. So let us see one or two questions and then we call it a day. Said a few grains of tablet salt were put in a cup of cold water, kept at constant temperature, and left undisturbed. Eventually, all the water tasted salty. This action is due to what? A. Convection. B. Osmosis. C. Capillarity. D. Diversion. E. Conductivity. Okay, now option A, convection. Is it actually correct? It would have been correct if constant temperature had not been mentioned, because convection also deals with the spreading of molecules, okay, from um, from their lower energy state to higher energy state. But there must be heat. There must be heat that is being supplied, and that temperature cannot be constant. So convection is out of it. Okay. Now osmosis deal with semi-permeable membrane, and it was not mentioned here. Capillarity deals with tube. Tube was not mentioned here. Diversion is the correct one, because diversion is what moving from higher concentration to lower concentration. Okay, and this few grain of stable salt are just done that, because if you are going to have a sketch of it, then we say that okay, let's sketch that statement that okay, maybe this is the this is the cup. Let's call it the cup, and this is the salt inside it. Okay, a few grains of table salt we are put in the cold water, so there is water in it. Now after some time, the whole water tasted. So this is higher concentration, and they begin to what? It begin to move randomly, okay, to a lower concentration. Okay, and that's why every part is now tasting for us salty. So the correct option is D. All right. So I will leave the other two questions for you to attempt and think of what the correct answer will be. Thank you for listening and have a wonderful day. Bye for now.